Chapter 7, Relations and Functions. A relation is a set of ordered pairs. So, wherever you see a set of ordered pairs, ultimately what you have is a relation. All right. We'll figure out what a set of ordered pair is as we go along. Let X and Y be non-empty sets. A mapping from X to Y is a rule which associates a unique member of Y to each member of X. X is the domain of the mapping and Y is the codomain. So here we're hearing that a mapping is a rule. You have two sets and there's a connection between elements in the two sets. That connection or the rule that assign a unique member of Y, which is the codomain, to every element in X, which is the domain, that rule is called a mapping. All right. So here is an example. Earlier we talked about a set of ordered pairs X. The set X shown here is a set of ordered pairs. Now, your set of ordered pairs may be viewed as a Your set of ordered pairs may be viewed as coordinates from or coordinates of points on a graph. Your set of ordered pairs may be viewed as coordinates of points on a graph. Below that, we have the set X, which has elements 2, 3, and 7. The set Y, which has elements 4, 6, 21, and 42. And below that, we have an arrow diagram, a relation diagram, or a mapping diagram represented the relation is a factor of. All right. So from that diagram, the arrows are saying are telling you the mapping. So we are seeing that 2 in the domain is mapped to what 4, 6, and 42 in the codomain, indicating that 2 is a factor of 4, 6, and 42. This is a relation of, or this relation is the relation, or this is the relation, is a factor of. All right, below that, what we have is a set of ordered pairs of the same relation, a set of ordered pairs of the same relation, corresponding values of what X and Y from the relation is a factor of. 2 again relates to 2 again is mapped to 4, 6, and 42. 3 is mapped to 6, 21, and 42. 7 is mapped to 21 and 42. All right, so this is a set of ordered pairs. All right, so the first elements in each set of ordered pair, the X elements are the domain elements. Now, the second elements, the 4, 6, 21, and 42, those are elements in the codomain. So the elements to the left, the X elements, are the domain elements. The elements to the right are the codomain. Again, so now early up in your understanding of function, one thing that you need to be able to do is you need to be able to state if a relation is or is not a function. All right, let's start off with the definition of a function. A function f um, from a set A to a set B assigns to each element in um, set a single element f of A in set B. The element in set B is called the image of A under F. So A is the um, A, common A is an element in set A, and f of a would be the corresponding element in what? Set B. The elements, the set A is the domain of the function, and the set B is the codomain. The range of the function is the set of elements that are images of A in this of common A in the set capital A. All right. A function. Simply put, a function is a mapping or a relation in which every element in the domain has only one image in the codomain. All right, so the diagram below, the R diagram below, we have the elements of A are A, B, C, and D. The elements of B are U, V, W, X, and Y, is an example of a function. Please note, all the elements of A of set A are mapped only to one element in what B. The elements in B are the images of the elements in what A. So the image of of A in A is U in B. All right. So this is a mapping diagram of a function. Every element in the domain is mapped onto only one element in the codomain. A is mapped to U, B is mapped to X, C is mapped to V, D is mapped to X. Every single one is mapped onto only one in the codomain. So I think I said earlier, A are the domain elements, B are the codomain elements. Now, the elements in B, which are actual images of the elements in A, those elements are the range elements. So U, V, and X are the range elements. So just writing at the bottom here, elements in the domain, which are mapped to elements in the codomain, which are mapped onto elements in the domain. Again, those are your range elements. Function. How to test for a function. Mapping diagram. A function may be represented as a mapping diagram, may be represented as a set of ordered pairs, may be represented as a graph. Now, how do I determine by inspection if an element, if a function, if a relation represented as a mapping diagram is or is not a function? Now, if only one arrow leaves every element in the domain, the relation is a function. If only one arrow leaves every element in the domain, the relation is a function. Emphasis on the word every. Now, if more than one arrow or if no arrow leaves any element in the domain, the relation is not a function. Um, a set of ordered pairs. Now, your relation may be represented as a set of ordered pairs. Now, if any of the domain elements in a set of ordered pairs is repeated, the relation is not a function. If any of the domain elements in a set of ordered pairs is repeated, the relation is not a function. So, if the domain elements are not repeated, then the relation more than likely is a function. Determining if a graph represents a function or not. All right. So, um, if a vertical line can be drawn, if a vertical line can be drawn that cuts the graph more than once, the relation is not a function. If you have a graph of a function and you can draw a vertical line that cuts the graph more than once, then that graph is not representing a function. But if every vertical line that you can draw cuts the graph only once, then the relation is a function. All right. Um, Example one, we're to determine whether the mapping diagram at the right is or is not a function. All right. By looking at it straight away, I can see that it is not a function. Um, 2, 3, 4, and 5 in the domain are mapped only onto only one element in the codomain, but one in the domain is mapped onto both A and E. So by definition, this is not a function because for it to be a function, every element in the domain must be mapped onto only what? One element. So since two arrows leave one in the domain, indicating that one is mapped onto two elements in the codomain, this relation is not a function. So I could say the relation is not a function. All right. Example 2. It says given set A and set B, consider the mapping is a multiple of, and we're to determine the domain of the mapping, the codomain of the what mapping is a multiple of. So I'm going to go with A being, so I'm going to put A over here, and we have 10, 20, 35, and 70. B, we have 2, 3, 4, 5, and we have 7 and 9. Um, so 10 would be mapped to 2, and 10 would also be mapped to 5. 20 would be mapped to 2, and essentially 10 is a multiple of what? 2, and it's also a multiple of 5. 2 and 5 can go into 10 without leaving a remainder. Um, 2, 4, and 5 are multiples of 20. Um, 5, 5, and 7 are multiples of 35. And 2, 5, and 7 are multiples of 70. All right, so this is an arrow diagram of the relation is a multiple of. All right, from just looking at this, I would say that the elements of A are my domain elements. The elements in B are the codomain elements. And I'm guessing that I can say that this relation is not a function. Now, for a relation to be a function, every element in the domain must be mapped onto only one element in the codomain. And looking at this, 2 is mapped to what? 2 and what? 5. 20 is mapped to 4, 2, and 5. So almost every element in the domain is mapped to more than one element. By definition, this is not a function. All right. Example 3. Is f of x equal to the root of x a function? Well, let's find out. Let us find a domain element. Let's select let us let x be equal to 9. So x is equal to 9 is a domain element. Now the image of x is equal to 9, f of 9 would be the square root of 9, which would be positive or negative 3. So in other words, and this would be my um, our codomain elements. All right, so in other words, um, x values domain, y value codomain, domain element 3. 9 is mapped onto codomain elements 3 and minus 3. So by definition, this relation is not a function because in every function, every element of the domain must be mapped onto only one element in the codomain. So now we have 9 in the domain being mapped onto two elements. Therefore, f of x is equal to the root of 9 is not a function. All right. Try these 6.1, which the following relation is a function. Give a reason for your answer. Remember, if one arrow leaves every element in the domain, the relation is a function. Where the arrows are coming from is the domain. Now, if more than one arrow, or if no arrow leaves any element in the what domain, the relation is not a function. So armed with that information, we can safely say that A is a function. Only one arrow leaves every element in the domain, indicating that every element in the domain is mapped onto only one element in the range. B is not a function. B is not a function. All right. Um, Y, E in the domain has no image in the codomain. Now, first of all, um, every image, every element in the domain must have an image, at least one image in the codomain. So first of all, if that's not the case, it's not even a relation, much less a function. All right. So C. Now C is not a function. And the reason for that is one in the domain has two images in the codomain. A function is a relation in which every element in the domain has only one image in the codomain. So one in the domain has two images in the codomain. Therefore, disqualifying this relation as a function. All right, so that's the end of lesson 1. All right, you can look forward to lesson 2.